you almost always have to do a go to next table or processing stops. And if you're writing the metadata, what are you going to do with that metadata?
Maybe you just need to write metadata which consists only the all bytes, yes, all bytes and non-bits of course in the mask. So in this case, you don't touch your metadata. But maybe you need to push it anyway.
Yeah, I mean, usually when you write metadata, you're going to use it in some later table.
Exactly.
But how do you get to the later table? You need to go to.
Yeah.
So how, if you could do one, only do one or the other, then that seems like, what? I'm confused. So
maybe it depends on the realization, the switch, and maybe it depends on the realization of controllers. But as I know, we need to do both.
yeah, we need to do both. Are you saying that that's allowed, or that there's some?
I think it's not allowed by the web specification, and I just try to understand how we can check it using the schema, because
this schema is not, we're still testing out the schema, so the schema might be buggy. But actually, so we can add another row, so we can put both of them. I didn't do that here.
I understand clearly what we can do it, but so my question is...
it allowed in the spec?
Yeah,
if it's not allowed in the spec, we'll fix the spec, because that's broken. But it could be that there's a version of the spec that has that problem, in which case it'd be like, well, you could never use metadata, because if you tried, then you couldn't go anywhere. The purpose of the metadata is to use later in the table, right? So you might say, I don't want to do my output here. I'm going to put it, or I'm not sure, maybe I want to tag this with a tunnel ID or something, but I don't want to set the tunnel ID. I'll put it in metadata. Basically it's a holding register. You put it in the metadata. But then you need to go to. So that's very interesting. In fact, I don't know if well, it's at the bottom of this page. My email address is Beckmann, 2 N's, Beckmann @brocade.com. So if you send me a note, maybe we can have a conversation about this, because I'm very interested. If that's in the spec, then I think it needs to be fixed. And it could be, but I haven't worked that closely on the spec. One of my vice chairs works more closely, and I think, if I remember, I'll have a conversation with him about this. Okay, so this is basically that. Once we've gotten to this point where we added the match fields, we added the go-to instruction and set it to L3. That's the mod. We've done what we said. So and of course we could go do other things as well. All right, now I've done it. How are we doing for time? Okay.
One question?
Yeah, sure. Good time for questions.
The table name that you are giving, like LLDP, SQL, and everything, so it's just for the understanding of operators. So it's in the switches, it's anyhow is flow tables. It can be any name you can give.
Right. That's just for us, right? That's just for the humans. One of the things that we're looking at is we want to be able to do more reuse. So if somebody figured out the right way to do, I don't know, ACLs, or the right way to do routing, or the right way to do tunneling, there might be 2 or 3 tables. And we'll probably end up having some libraries. And in that case, the library might have a table name. This is one thing we're trying to figure out. If you're using in the future, if there's TTP libraries, then you may be forced to use the name that's defined in the library. But it's not a name that's defined in the spec, and it's not a name that's defined in the chip. It's us humans, us designers.
So following the same situation, so the broadcast itself, you define the DPA API, so you use the flow tables pipeline, so there's a name like L2, L3, like that. So as application developer, we have to respect that table structure somehow. We can change in this point.
Yeah, I mean, it depends. So I could go back to the picture. Actually, I do want to have that kind of conversation. Let me just see if we're done with our exercise, because then we can go back and talk about kind of the larger architecture. I kind of think that some applications may talk well, I'll go back to that picture later on, that in some cases you'll have to be aware of the table names, and in other cases you'll use an API that you don't think about the tables. Okay, so I didn't actually go through this step here to, because my editing window was, I already had done this last night. Did anybody try this? Did you paste the TTP? You find a TTP in your zip file? Yeah? Mostly worked? Okay.
At least parsed.
Huh?
At least it was parsed.
It was parsed? Yeah. And then we can go the other way as well. So after we've gone and made the edits, every time you make a change to the form, we click on a button, it should be updating the TTP that should be updating, I'm sorry, the JSON in that little window. So that window is good for, it's kind of bidirectional window. You can paste something in there and click update, or every time you make a change using the form, clicking the buttons, the JSON also changes, and then you can copy that out. I mean, maybe later I'll change the website so that you can save to a file. But from my perspective, it's just about as easy to copy it out. You just select all in that little window, and you can save it to a file. Of course, sometimes the problem is that you don't have a handy editor. The editor saves it to .text or whatever, so who knows, maybe I'll change that and add a download or an export or something. Anyway, so that's what all this is about. To paste in, modify, and paste out. We already looked through the TTP. Yeah, there's different fields. In fact, yeah, you mentioned somebody mentioned features earlier. I think I might have taken that out of the schema just because I wanted to have it be I didn't have anything useful to say about features, but it is part of the spec and it should be in the schema. So this is sort of in fact, I mentioned that somewhere in the text, one of the bullets said that this is not the real schema. One of the reasons actually that we'll get to, okay, I didn't have the table map. Well, should I go back to the table? Nah, I'm not going to go back to the table map. Okay, we looked at this already. These are the instructions which I went through just looking at the browser or looking at my web page. But if you're doing this yourself at home, this should be a bit more clear. Instead of the instructions that we had earlier, I think the pictures make a little more sense. You can click, add another flow mod type. You can add an instruction. You can do these different, add match fields. And all of this is the Jeremy Dorn work that I just took advantage of. I definitely want to give him credit. Good stuff. I mentioned that we go to the next table using the built-in flow mods. We added a new flow mod type, which is essentially a template for flow mod messages, and we add the instruction to go to table 3. And then, as I said, it's updating in there. You could go, you can scroll around and find, or you can use like Control F typically, and find basically the new table or the new flow mod type that you entered. It'll be in there. It's gone wrong, but this seems, when I've been messing around with it, it's actually not that fragile now. And so it seems to work the way it's supposed to. What did we do? We actually changed the way the thing works. And I went through the same tool. We could do this if time permits, but it's easier to do it sort of looking over each other's shoulder, or I'll flip out a PowerPoint and try it on my laptop. See if I didn't do it last night, so I may have forgotten how, but I think it'll figure out a way to do it, to run the, you need like Java 7, if I didn't tell you that part. So if you unzip the TTP utilities, oh shoot, I needed to change something here. Sorry, that was my previous workshop, MWD2. So I need to change that to use the right TTP name. But anyway, what I did is I run the parser, and this is useful, so that'll remind me how to type it, and I just have to get the right file name in there. And it'll absorb the JSON file and run through, and it spits out, unfortunately, it regenerates the JSON, which fills up tons of pages. And at the very end you get these 8 lines or whatever it is, 7 lines. And this is the interesting 7 lines for the utility. But I did all this once already, so we don't have to do that here. And essentially there's one more line here. So Previously, we didn't have the ACL to L3 linkage. And so the drawing before had this, and then it went here, and then it went to both of these. And now it's added this other arrow, and it also moved where the tables are, or where the circles are, which represent tables. And so it looks slightly different, but basically it's the same picture with one more arrow. And so that basically, like I said before, this graphic kind of validates, yep, that's what I thought I was doing. Eventually, I can imagine that we generate pictures like this, and I mean, we'll decide if people find it valuable, that you go click on this link and say, okay, under what circumstances does it go from here to here? And you click there, and it opens up, it tells you what's the conditions, like what's the match terms. When do I go from ACL to L3? And it can tell you when that happens. The utility that we use to generate this, converts this to that basically, is something called a graph viz, which is a collection of command lines, and I used Nito, and it's you say Nito and you give it the file name. I guess I'd have to go look again, but and then that's a .png output. So it's a pretty simple command. I'm sorry I should have it written down there. But I just figured it out from the help file. It's very easy. And so, like I say, this, we changed it and it shows up in the graphic. Here's the, yeah. And this is the other thing. This is the beginning of that mapping function. So going back to the picture, which I think I may have. Yeah, this picture. So I mentioned before, well, we've got simple use case oriented ones and probably complex ones down here. There's a bunch of different paths we sort of talked about that a packet can do as it goes through a pipeline model. And so this is a simple pipeline model. It has a bunch of paths. This is a complex pipeline model. It has way more paths. But what I want to be able to say for every path that's here, and there might be a dozen paths, maybe it's only 9, whatever, 6, I need to be able to do the same 9 or 6 down here because my use case depends on those 6 or 9 paths. So how do you do that? Now I'm going to scroll back up to where we were. What we have is in our utility is the ability to look at the set of paths using the Open Daylight utility. And I can ask for flow paths, which it says, well, one case is when it goes into the LLDP table, that first table, and then it goes to the controller, in which case it doesn't go to any more tables. So there's a one table option. There's a case where you go in and then it goes to the ACL table, and the ACL table says, it matches the drop condition. It says, okay, this is a bad frame or bad flow, and it stops. So that's another case. You notice there's no case where it stops at the RMAC. If it gets to the RMAC, it's going to go one of two places. So basically it says it's not a link layer packet. I don't need to drop it. Then let me check and see if I need to route this or switch it. But it'll either route it or it'll switch it. It'll never drop it or it'll never send it to the controller, right? So you can sort of see, okay, these are the 4 basic cases in my original TTP. And then when we modified it, now we have a new path. Basically it adds this other case. It goes from here to here to there. And so each of these different paths through the forwarding model, or basically the switch model, what am I calling it? Pipeline model. I knew it was a P word, pipeline. Each of these needs to be handled, and needs to be controllable. So we got to go find each of these equivalent path in a more complex device. So I would go look for this in the Broadcom device. And this is what the utility will do automatically, probably in about 3 weeks. Like next week, no travel. I just sit down and start decoding in Open Daylight, and hopefully I can get this where I can find these in my simple TTP, and I find there'll be like 100 or 200. There's like a lot of them in the Broadcom TTP. And then I can compare. It'll find, okay, this is checking on MAC address, and this is, you know, checking on a 5 tuple, and it does a drop. So you combine the matching and the actions, and it'll tell me, you know, there's a bunch of, there are several paths that look like this, and there's several paths that look like that, and I should be able to figure out how they all work. And then before long, we'll be able to actually also test it. Okay. 15 minutes. Do you want to, is this a good place to pause? No, actually I want to go to that graphic again in a minute, what we were just talking about. I'm sorry, I forgot the question that you asked. I said I'd answer it.
Yeah, this is from the OpenFlow point of view, you mapped into the particular device, so what I was talking about, but it's in the device that you have the DPA graph.
Okay.
So you have the hardware-based flow table pipeline, so that's what I am talking about.
Okay.
So it's in DPA, you know, from DPA API. It is.
Like that? These pictures, yeah. What's the question?
So the names that you are saying here, so whoever application developer has to respect all the time, so in the first time we can change, so there are two parts.
Yeah, so I mean these names are really long. I think the OFDPA does have sort of longish names, and if you are talking to it, I think you probably would have to respect those names. But
so you not avoid the conflict with other developers or other applications running in the open daylight?
Actually, what we probably have is this TTP has a name, and so it'll probably, in order to avoid conflicts, because there might be a lot of TTPs that have L3, right, or something simple like that. So we'll probably precede the L3 with the TTP name, which should be unique, and then some colon or something, and that way, but yeah, you'll still have to respect it. Although I don't want to be too strong about that, because there may be other APIs, you know, still working with the controller side to figure out what does that look like to the application. You know, yeah. The API name or the table names, I think in the early days it'll probably be that you have to be aware of the table name, but it should be documented. Maybe it's just documented in JSON, but probably it's in a more human readable thing. Okay. Now I wanted to talk a little bit about, okay, I think this is where I was. And I think I've got like 6 or 7 slides. So I said this was not this is not officially the 1.0 schema. Partly I deleted some stuff to make the tutorial simpler. And that was more for an earlier version of that editor was really messy. Probably with this version of the editor it's getting simpler, and I could put the full schema in, and I'm going to go back and work on that next week too. Next week's busy. Right? But this still was not official ONF spec for TTP, and part of that is because our original TTP spec we didn't really think about. We focused more on humans and less on machine consumption, and the good news is machine consumption happened like right away, and that makes it more powerful. Basically, humans don't really want to read JSON anyway. They want to read PowerPoint and they want to read other things. JSON is not that visible. And so we'll do things using schemas, machine readability, the form editors like that. And so we probably won't spend a lot of time in JSON, we as humans. And so we're shifting for 1.1, instead of focusing on the humans, we're going to focus more on schemas and tools. And then the human doesn't need to read the JSON directly so much, probably read it using a tool that is schema driven. So one of the things we had was the table map it was difficult to do. I don't know if I mentioned, so Open Daylight, I mentioned that we can process TTPs with Open Daylight. They do that by writing a Yang model. The Yang model describes a TTP, and some things were difficult to describe in Yang. That's what really is driving us to make some changes. For example, one of the things, if you remember the JSON that we looked at, you could have a document string, which is really just a comment string. Or you could have an array of strings, and that was annoying. It's like, well, is it an array or is it a single string? And either one was allowed by the spec. But you know, we could make it always be an array, and sometimes it would just be an array of one string. So we're doing those kind of things to make it simpler on coders, basically, so that it'll be much easier to make tools and easier to make editors and things like that. We had some identifiers. We shortened them. That's not hard for a schema, actually, but Open Daylight already uses the openflow.h file. It uses it for lots of reasons, and it would be convenient if we just used all the identifiers that were in the openflow.h file, but when we shortened them, then they're no longer the same. So that was convenient for humans, again, to say, oh, okay, well, they don't have to type so much, but it's not really that convenient for actually it made some other humans have to type a lot more. Instead of having it all in an existing header file, no, we had to go enter these values all over again. So we're going to go back to the openflow.h version, so then we don't have to do as much typing, which of course has the possibility that you mistype something, and then you have a maintenance problem. So instead of having the short names, we're going to go to the long names, and that's actually better for the software. Benefits of the schema-driven stuff, much easier to maintain, so we can go change the schema, and the editor changes with us. We looked at other things. Actually, the OFDPA was created by They created massive structures in Excel, Broadcom people did, and then they used some Visual Basic to generate the JSON. So they did like mechanical export. And then the problem is that suppose you want to use someone else's TTP, they have no mechanism to take the TTP and go back into Excel. So that's why moving to the schema-based model works much better. There is a bit of variability, like there's some keywords in the schema that are not standardized. That seems common. But we'll probably have two kinds of schemas. One that is very basic, no extra features for like editors, and then we'll have another one that adds the features for the editors. We're still working that out. Current situation. Our best example of a device TTP is the OFDPA. I tend to think of them as that OFDPA is a TTP, etc., but it's actually more than a TTP, as I was reminded yesterday. But it really does expose the power of the Broadcom chipset in OpenFlow. If you didn't have that documentation, it would be very hard to write code on Broadcom. But even so, I want to move beyond that and not just write code that runs on Broadcom. I want to write code that runs on whatever you got in your data center, right? Which you might have 2 or 3 or 10 vendors, and whatever you're going to have in your data center next year, which maybe you don't even know yet, right? And we want to have those higher level TTPs that we call app, or sometimes app layer. Sometimes I call them use case. Basically, more abstract TTPs that are not close to the implementation, but we can connect them to the implementation. And I think these are much easier, and they're much simpler, but they should be pretty easy to create. And then the question, as we sort of talked about before, it's not that hard to create it, but it's the second question, can it run on boxes that I can buy? And I think we'll be able to tell that. It'll get easier and easier because we can test that with tools, or you can look in documentation and so on. Beryllium is the upcoming release of Open Daylight. It'll come out early next year, I think, like February. I'm not completely sure. And we're adding more of this, the ability to connect that abstract TTP to the device TTP. It'll probably be, because the best device TTP right now is the Broadcom, so we're kind of focusing on that. Then my hope is actually that the other vendors, when they see that this will be good for Broadcom to have good support in Open Daylight, then the other guys will say, yeah, and they'll join the picture. Onos uses TTPs in their architecture too. They don't import them, but they use them for essentially driver design. So it's more like a TTP concept more than a TTP file.
So if UNOS and RDL start being more complementary in terms of their relationship, do you see this going to TTPs exclusively instead of the
Flow objectives?
the flow objectives?
I think basically flow objectives are similar to the abstract TTP, but I think they're slightly more abstract. This is being kind of worked out. I think they are aiming to go a little bit higher up the stack, and like they may not be specific to a device. They're not as device oriented. TTPs are still kind of device oriented, so I think they might be the layer just above TTPs. But I think, yeah, basically they'll come together. Flow objectives are not actually specified yet, except in like PowerPoint or something, where you know, I don't know exactly what the format is or what actions are allowed, or you know, it's a bit more early days for flow objectives. And I think what that's good, it gives us the ability to do that kind of complementarity thing. So we already talked about this. We went back and forth a little bit, but I do put it here because it gives us the opportunity to talk about it a little bit more. Essentially, we have a good one of these and a good one of these. We're making a mature version. Essentially, did you hear some discussion about Atrium? Did I ask this question already? Maybe when fewer people were in the room. Atrium is an open source project that's part of ONF, and they're essentially trying to do a demonstration case. I think they had plans to do something even bigger, but I don't think they realized quite how hard that would be. Essentially, building a model where you can support many different devices, and this is where they have like special drivers for the devices which are different. So I think they support 7 devices, but they only have 5 drivers or 3 drivers or something. But they do have some. And I think that was sort of educational as well, the fact that you do need some different drivers to deal with the differences in the devices. And then they have the flow objectives up above that and some code that maps the flow objectives, which are like abstract, you know, user needs or application needs. That sort of highlighted this and helped expose some things, which we anticipated again, but it's different between anticipating it and actually seeing it in real life. So the good news is that this is firming up, and we've got stuff here. Oh, what I was going to say is they have flow objectives was defined in Atrium and originally delivered on ONOS. They're doing the same thing on Open Daylight, but we're creating a TTP that represents those flow objectives. So from the Open Data Path Working Group, we kind of see flow objectives as very similar to this. I see them as similar but slightly different. Okay, and I talked about the mapping already, so I already basically covered this slide. Essentially, there's many different ways to get through a model, and you just need to make sure that you can do kind of the same things, not just kind of, but functionally, identically, the same things in the device. And this is a partial list of all the flow paths in the OFDPA. I just picked out, 30 of them or something. I think it's a couple of hundred. I misspoke and said it was 1,300 one time, and that was human error. It turns out there's a few hundred, and it comes at the end of a file that has 1,000 other lines in it. And so I just did a line count on the file, and it turns out I was off by 1,000. So there's 200 or 300 of these different paths, which is, it's quite a complex chip. I don't think, as I mentioned before, you probably don't use this chip to do all the things it can do at the same time. So you're using some subset of it for whatever your needs are. And that's why, that's exactly what we're doing in this mapping experiment. We try to figure out, okay, I want to use this path, and I want to use this path, and I want to use this path to do the 8 paths that my use case requires. Now, I think it was 5 or 6 in my simple use case. More realistic use cases that we've looked at probably have more like 10 or 15 or 20 paths, but they have less than 150, more than 3 or 4, and that's basically what, if you're an SDN network architect and you're trying to create an application or create an architecture, we need to figure out what are the different processing steps. And we may have one of those use cases might be a top-of-rack switch. One of them might be a core router. There may be a WAN edge router that does mapping from, say, VLAN to MPLS tag. There's just a variety of ways in which this stuff will really come and iron out over time. I thought I was going to run over time, but I ran out of slides. So we have like 1 minute for questions, but actually I have a little bit of time. If you have a little bit of time, I'm happy to talk a bit more. If you got stuck on something in the exercise, let me know. Questions? Did we get some sense? Did you get some sense of how TTPs, how they fit kind of in the ecosystem? How basically vendors or operators could potentially define a TTP to say this is what I need. You can have examples like the Broadcom, but hopefully we get something from Intel and Marvell and other people about, okay, this is what my box does. That'll help you like look around, okay, I want this feature and that feature.
I understand how it plays within the communication to say to the device, this is what I have, what can you do with me, right? But then in the end, how does that modify the OpenFlow communication?
Yeah, so that's a good reason to go back to this picture here. So the application will say, like you say, you design this up here, and then the utilities that we have will generate probably the original step would be a little bit around that performance thing where we'll create some table, and so you'll get a message and you'll have to look in the table and then figure out how to modify the message. A more compiled version would come in through a particular API and just modify it directly. So this is, what code you generate for do this mapping is essentially your question, but there will be code. Initially it may be table-based and maybe a little bit slow, focused just on the interoperability part of it. And then very quickly, I'm sure performance will matter. But once we get interoperability, then you're like, okay, I don't want to like recode that many times. Once the interoperability is there, then I'll invest the energy to compile it.
Is interoperability, and once that's done, you can start building on top.
You can optimize for performance, yeah. But this is not, there's other optimizations as I mentioned very early in the talk about, like, well, just as an example, OpenFlow does not force you, the spec doesn't say that you should send certain match fields in any particular order. So you might match on 4 different fields and they can come any order, and that's allowed. And it seems like that's a bit, I mean, it's, the software is going to send it the same way every time. And the hardware, or the code, it'd be convenient if it was always in the same order. So there's an opportunity there to do an optimization instead of having to compare. And then sometimes you could like send a field and mask it. There's a bunch of as you're writing your code in the switch side, you have to do all kinds of checks, even though it'll never matter. And yet you have to do all these checks. And so I think there's some optimization that'll go on there as well. So there's performance, and I think we have some work to do there. Of course, we have these really powerful processors that let us get away with murder, but it's like, man, if we do a few clever things, we can still, take our 10,000 flows a second and make it 100,000 flows a second. 10,000 is good for lots of applications, but I'm sure that there will be more applications where you want 100,000 or a million. Yeah.
It's understandable that we can discover what the tables and the switches and get the idea of what it can do this device. But can we do vice versa to program what amount of TCAM have to dedicate it to the what table, some kind of dictate away from the controller to the switch, to not just. I think I understand how many RAM I have, how many TCAM I have, how many tables I can have theoretically, and then you can understand my pipeline. I can program the certain needs in more optimized way towards the switch, but it seems it's every vendor goes different way on this direction. Do we have some kind of plan to standardize that or make some kind of protocol And new protocol.
Yeah, that's a very good question, and I wouldn't go there except you asked. I wouldn't talk about it otherwise because it's a little bit complicated. But the answer is yes, there is plan for this. There's been some work on this for a couple of years now. There's if you're interested, there's something called P4. P4 is a language, and they come at the problem from the other side. So basically, we work backwards because we were told to work backwards. Basically, we originally, going back 4 years ago, we were saying, oh man, we could create a new language, we could describe pipelines, we could be very powerful. And they said, it has to work with OpenFlow. All right, so we went the other way. But then like a year or two later, then they invented P4. They came out of like Princeton and a bunch of stuff like that. And the ONF is working with the same group. Many people are, many of our members are also very active. In fact, Brocade is also active in p4.org. And you can go and look there. Now P4 is kind of in the early stages. It defines the pipeline. It can do what you said. It said, okay, I'm going to put the, now this is all just a language, right? That's not the same as a device. But in parallel, there's other groups. You might have heard of Barefoot Networks. Barefoot Networks is, and there's a paper a couple of years ago, even before I really heard of P4, where they were talking about a highly programmable chip, where you can take the TCAM, put it in this table, put it in this stage, or maybe take 3 TCAMs, etc. The silicon doesn't exist yet, but they're planning to do this exact thing, where you take the P4, define a pipeline, compile it, then you have to download it, reconfigure the silicon. Now you have the pipeline that you want, right? And you can do this today in an NPU, very soft, but probably not as fast as an ASIC. The Barefoot Network, they promise a chip that is basically as fast as an ASIC and only slightly bigger, only slightly more power. We'll see. I think, and the other problem is that we need all the compilers right, we need the language, et cetera, et cetera. So it's very early, but in terms of is there a plan, there's definitely a plan. It's probably, you'll probably see a demo in a year from now, but the demo that you see a year from now will be kind of like OpenFlow was 4 years ago. And the good news is we now have controllers and so on, so I think the uptake on P4, oh, and some people sort of say, well, P4 replace OpenFlow? Well, not really. P4 is a pipeline language. They don't define the control language, so we'll probably enhance OpenFlow so that it can be the control language that P4 needs. P4 needs a control language. They don't really care. They care more about the pipeline. And of course, OpenFlow needs a pipeline. So we will work on being friends with each other.
Yeah, and that's p4.org, and anyone can join.
Yeah. So that'll be powerful. Will the silicon, and I think eventually the silicon will be flexible.
If openness can be standardized among the vendors.
Yeah, it'll be quite similar in some ways. So right, we were talking about we can define a TTP, and then the question is, does this work or not? So in P4, you do the same thing in P4, and maybe it'll work on some silicon but not some other silicon, right? Probably, as things mature a little bit, then 99% of this will work on the silicon. But maybe you have a table, well, it only supports 4,000 entries, and I want 8,000 entries. Well, then you have to buy new silicon, right? And so this silicon will be more standardized, just like x86, but also not every x86 is the same, right? That's why the X is there, right? The 186 was different from the 286, and et cetera, but now they're more and more similar. And more of the code, you don't have to worry which one it goes on, right? Instead, you worry about which operating system, or which NIC card, or is it SRIOV? You worry about something else. But anyway, yeah, this will advance and move forward. On the other hand, maybe more of our networking gets done in a server. It gets done in Open vSwitch, or it gets done in a VNF. We don't know yet, right?
Right.
Yeah.
It's always a question. But also, like I said, just returning back from your knowledge about, like you say, all of the assets, yeah? What you seen in the trends, especially, let me say, just looking for again, like, yeah, how wide the merchandise silicon, like the Broadcom are now deployed at the top of the racks, yeah? Again, like all of our question that you come from ideology, how widely you can deploy, let me say, OpenFlow-based solution in WAN networks, yeah? Because precisely in WAN, yeah.
In WAN
again,
networks?
Not in, again, like, not in the data center, because let me say, whereas again, it's somehow, say, this one's already covered, yeah? But if you talk about the WAN, and also again, like we follow the questions about buffering, because say like, yeah, that follow what Evgeny mentioned about TTPs, yeah? Understanding, yeah? Have you seen some trends that actually, for example, Broadcom on the next generation one that will soon come, yeah? Yeah.
Well,
Production will really allow to do this one, yeah? Or make some, I don't know, like partial TTP manipulation.
oh, manipulating the structure?
Yeah.
Yeah, you know, I think you make a good point, right? If I understood your point, if you think about it, the early demonstrations of SDN and the value of SDN, ASICs. But of course, those classic ASICs are limited. So the Google network, that's sort of OpenFlow-based Google network, Internet 2, those use existing pipelines. I think Broadcom and other vendors are eager to figure out what it is people want. Like, okay, you want to be able to move things around. Do you need complete flexibility like barefoot networks? Or is there some limited flexibility that is easier? And, you know, I think they will do that. I think in some cases they may already have some limited flexibility. And now how do you expose that? You can't really expose it very well in OpenFlow, but maybe with P4 you can expose it. I don't know if I'm exactly answering your question. And then the WAN one, like, I mean, actually the Google use case is a WAN use case, but what they do is at the edge of the WAN, of course, right? Because they own their own fiber to some degree. And then Internet 2, same thing. But if we're going to do a generic thing, we'll end up using just like often in the data center, right? We use the existing networking infrastructure as a substrate. It's just a transport layer. And the SDN happens at the edge in the vSwitch. Similar thing, we may use the WAN as a transport layer, and we put the SDN at the edge, kind of runs over the top. And so it depends on your carrier. If you are a carrier, then you can implement that in your transport. Right?
In that case, you always come to the, for example, the TCO of the model, because it creates another nicely overlay. Yeah, this is always where's about the office. Yeah.
Yeah.
The flexibility of the services, and that you should, let me say once more time, again with the pets-based channels. Yeah. I can say concept, you always should rely on top of your application to just run this infrastructure, yeah?
Yeah.
We talk about, let me say, B2B customers normally, yeah? You'd like to see the something what they right now already getting, yeah, from the Cisco Juniper development, yeah? Stability and integration, yeah? And right now we're just providing the sound very nicely point to them to really to move in this direction. But finally we just drop them off, yeah, let me say, like, yeah, all of the stability, yeah?
Yeah.
Actually, practically.
How much of that is the boxes, and how much of that is the controller infrastructure and well-defined APIs and?
Yeah, it's all around here again, like application driven though. It's a well-driven application.
Right.
And that's why like try to just let's say enforce any type of the enterprises to resolve this problem.
Yes.
I got a question. I don't know if it's exactly in your topic, but I would like to put the question. Like OpenFlow is all about flows, right? It's all about flows. Now, nowadays the bit time of a 10 gigs is about nanoseconds. But it's still like, for example, when you miss a link for some reason, okay, it takes 3-5 seconds to get back the thing to be working because all the protocols, the BGP, whatever you implement.
Yeah, and TCP, you know.
Now suppose that the protocol or somebody else has created a technology that allows for converging quicker instead of seconds to nanoseconds, right?
Or at least maybe microseconds.
It wouldn't be a flow, it would be a whatever feature. How you guys are thinking on to address this kind of thing? Like, still the controller, you have to order something to the chipset. Okay, it's not a flow.
No, that's a very good point. I mean, it's interesting, I hear some people talk about the difference between packets and flow. I feel like OpenFlow doesn't distinguish a lot between packets and flows, so you say flows, and I agree. But it doesn't seem like that's not the point you're making. You're saying, to me, most of what this is talking about, the events that we're looking at are packets. But there are other events. Like you said, when a link goes down, that's a different event. You know, the events for a flow are packets, but the other network events are link down. And that's not a packet, not a flow. It's a different event. And OpenFlow roughly recognizes that that can happen, but they don't really go into detail. So they sort of say there's a mechanism in the group entry that allows you to do fast failover, local failover. It says if the link goes down, choose the other link, you know, so that you can have an alternate link defined in OpenFlow. But they don't spec exactly how that works. They say that the details by the switch implementer. That's not exactly interoperable, right? I mean, it can probably make it so it kind of interoperates, you know, but it seems like that's out of scope, right? There needs to be like some separate documentation or some separate spec. So, you know, maybe if Open Daylight says they want to support failover, then we'll have to write some spec, and then switches will have to support it, and those kind of questions. And so that is a bit of a weak spot. I don't know if P4 talks about that or not, but I mean, you make a good point that it's not. We haven't really addressed that yet, and it's a very important need. There could be other events too, like congestion. Congestion is not exactly a flow. I mean, it's partly happens when you receive packets, so it's kind of packet related, but it's still a queue can build up, and then you detect that you have congestion, etc. So that could be an event, and you say, okay, I want to make different decisions now, and trigger a set of actions. But we don't really have that either. So those are very good points. I'm glad you brought those up, actually. It makes me want to think. We're a few minutes over. I can go for another 5 or 10 minutes, but I'm also happy to call it a day. Any other questions?
We want to thank Curt for helping out. Again, his email is in the deck, right? Or if not,
Probably.
Yeah, we'll post this on the ONF YouTube channel, be available for everybody. Thanks for being here. I'm
easy to find, Beckmann at Brocade, 2 N's, Beckmann with 2 N's at Brocade. Yeah, thanks very much. Thanks for listening to TTPs. Basically, to me, TTPs represent interoperability, but I start talking about jargon and buzzwords and acronyms right away, and people often don't realize I'm trying to talk about interoperability. So, yeah, make sure when you mention TTPs, or if you think about TTPs, remember that they're about interoperability. See you around. See you at the next conference.